Welcome, pre-algebra class, to the one and only episode of the week. This lesson is on Indirect Measurements, lesson 10, page 238 in the book. Okay, so what is an indirect measurement? Sometimes you cannot measure the length of two sides of a similar triangle, or more than one side of the length of a similar triangle. So, when we look at similar triangles from the previous lesson, it might look like this, right? Where there's three angles that are corresponding, which means that there's three sides that are corresponding. And you can't always measure things in real life because sometimes things are just too large to measure, so you have to use indirect measurements. One of the ways to do that is with this thing called shadow reckoning, where you look at the shadows of different objects to be able to make triangles out of it in real life. So, for example, let's say that we have a new statue of Dobby at KAS, and this shadow on Dobby is 43.5 centimeters long. Actually, I'm going to use this handy straight line tool. There we go. Look at that. It's 43 long, and this is the height of the Dobby. So if we look at the height and the shadow that it casts, and then we connect the end of the shadow to the top of the statue, then we get a triangle, right? And that's it. So let's say that York is standing over here, and York is like, "Hey guys, I love looking at the statue of Dobby. Yay, Dobby." And let's say that York has a shadow, and York has a height, and if we connect the top of York to the edge of his shadow, then you would have another triangle, right? And let's say that York's shadow is 32 centimeters, and let's say that he's 160 centimeters tall. I don't know actually how tall you are, York. I'm sorry if you were actually taller than that in real life. Can you guys hear me? I just realized that the microphone was behind me. So, in making a proportional relationship between these two, we can find the value x. That is how tall Dobby is, right? So let's say we write a ratio of Dobby to York. And so the length of Dobby's shadow is 43.5. And if we write that as a ratio to York's shadow, that would be 32. And that will be equal to the height of Dobby, which is x, we don't know what it is yet, and the height of York, which is 160. So then we just cross multiply, right? 160 times 43.5 is 6960, and that equals 32x. We divide both sides by 32, and we get x equals 217.5. So that means the statue of Dobby is 217.5 centimeters tall. Okay? All right. Your turn. So let's suppose that the jungle gym, the thing next to my classroom that has the ropes that you can climb, that's the jungle gym. Let's say that it casts a 27.6 foot shadow at the same time that Mr. Juergens casts a 1.2 foot shadow. If Mr. Juergens is 6 feet tall, how tall is the rope jungle gym? And remember, if you're doing this at home and you don't know how to answer this, feel free to just go back and watch the example video again. Okay, so the jungle gym, let's say that it kind of looks like this, right? It's a bunch of ropes and they're all connected. But anyway, It is some number of feet tall. We don't know how tall. And the shadow that it casts is 27.6. So this is a triangle. And then Mr. Juergens, let's say that he's standing over here and he's 6 feet tall and he casts a 1.2 foot shadow. So this is 6 feet. This is 1.2 feet. The jungle gym casts a 27.6 foot shadow, and we don't know how tall it is. So we can write a proportion of the jungle gym to Mr. Juergens. So we could write this as x over 6. This is the height of both things, to 27.6 over 1.2, which is the shadow of both things. 6 times 27.6 is 165.6, and that equals 1.2x. We divide both sides by 1.2, and x equals 138. That means a jungle gym is 138 feet. It's not in real life, but that's how tall it is in this problem. Okay. Sometimes when you are using similar triangles, you don't get shadows, because shadows are only for things that stand up off the ground, and also there has to be a shadow, so that means the sun needs to be out, right? But that's not how life always is. So in this next example, we can look at, let's say if we wanted to know how far it was from one end of a pond to the other, and we can't measure that, but we can measure a triangle that's next to it that we know is similar. So we know that STU is similar. STU is similar to VQU. And this triangle is just a reflected version of this one. But anyway, we'll talk about that some other time. We can prove that these two triangles are similar. So STU, we can do big over small, right? So this side right here is 16 over the side of the small one, which is 10. And then we do the big one, which is this. That's what we're trying to figure out, right? And that's x. And that's going to be over 20. So 16 times 20 is 320. Yes, 320. Over 10x, divide both sides by 10, 32 equals x. So what is the missing measure? How far is it across the pond? It's 32 meters. 32 meters across the pond. Okay, your turn. Let's say that these two figures are similar, and they are QRS and URT. Find the missing measure. Welcome back. Okay, so we're going to go, let's go big over small again. Big over small. So x is going to be proportion, or a ratio of x over 60, and then the next ratio will be 138 to 46. And remember that these are the corresponding angles. If you get confused about which one is which, Q is corresponding to U, R is corresponding to R, and then T is corresponding to S. And you can see these are both right angles. Okay, so anyway, 60 times 138 is 828 equals 46 times x is 46x. Divide both sides by 46, and that equals 18. So the distance from the mess hall to the cabin is 18 yards. Alrighty. Happy short week. Bye. Nope, that didn't end it.